This lesson is called Graphing Quadratics Day 1. So we're going to start off by just reviewing the standard form of a quadratic. We've seen this a couple times now, where the standard form of a quadratic is ax squared plus bx plus c. So when we're in standard form, the leading coefficient is a. If a is positive, so plus a means the graph opens up. So it's going to do something like this. If a is negative, so negative a, means the graph opens down. So it's going to do something like this. So the a value, then that number that's in front of x squared, is going to tell you which way your graph opens. Then we have our x term and then our constant term c. This c is the y-intercept. So in these two examples, we're going to go ahead and identify a, b, and c, and then state, does the graph open up or down, and what the y-intercept is. So in example 1, I have 9x squared plus x minus 15. So I'm going to identify a, b, and c. So a is the number in front of x squared. That's positive 9. Make sure to include the sign. The b is the number in front of x. There's not a number there, but we can assume that that's a 1. So our b would be 1. And c is this last number right here. It's the thing without the letter. It's negative 15. So let's go ahead and answer the questions. Does the graph open up or down? So we're going to look, a is 9. We identified a. 9 is positive, so this means the graph is going to open up like that. And then what's the y-intercept? The y-intercept is the c value. It's your constant. So my constant is negative 15. So for my y-intercept, I'll just write negative 15. And if you'd like it as an ordered pair, you could say it's 0, negative 15. Number 2. Negative 2x squared plus 1/2 x plus 2/3. So again, start off by identifying a, b, and c. A is the number in front of x squared. It's negative 2. B is the number in front of x. It's a half. It's okay if that is a fraction. C is 2/3. Now let's determine which way does this graph open. So I'm going to look at the a value. The a value tells you, does the graph open up or down? My a value is negative. So if a is negative, where I have negative a, means the graph opens down like this. My y-intercept is 2/3. Again, if you prefer the ordered pair, you could write it as 0, 2/3. So this is how you use standard form to identify which way the graph opens and what the y-intercept is. So you do want to know what your a, b, and c values are. Examples 3 and 4, I want you to give these ones a try. So hopefully you gave number 3 and 4 a try. In number 3, notice there was no x term and no constant term, so those are both 0. And then my number in front of x squared is 1. So my graph is going to open up because a is positive. My y-intercept, I don't have a c value, so it's 0. So my y-intercept will be 0, or the ordered pair 0, 0. In number 14, I have 17x squared plus 3. So I don't have a b value, but I do have an a value and a c value. My a value is positive 17, so that means my graph is going to go open up because it's positive. And then my y-intercept is 3 because my c is 3. So the next form is the vertex form of a quadratic. So the vertex form of a quadratic is a times x minus h squared plus k. So, and in this form, the vertex is h comma k. So, but the same is going to be true. Plus a opens the graph up. Minus a, the graph opens down, like that. So we can still use this value of a to determine which way our graph opens. And then we'll also be able to identify the vertex. So let's look at an example. So f of x equals negative x minus 3 squared plus 5. So we're first going to identify our a, h, and k. So instead of identifying a, b, and c, this time we're identifying a, h, and k. So my a is the number in front of the parentheses. So this would be -1. This is my a. My h is the number inside, and then k is the number outside. So the first question we want to know is, how does this graph open? So let's identify. A is -1. It's negative. So since it's negative, remember, when a is negative, the graph opens down. So it's going to do something like this. The vertex, remember, vertex is h comma k, and h always gets the opposite sign. So what's the h? Well, it's written there as -3, so I'm going to rewrite it as +3. And k gets the sign that we see with it. So k is +5, so I'm going to leave it as +5. The domain for quadratics, the domain is always going to be all real numbers. What this means is I could put any number I want in for x. So the domain is all real numbers. The range is the one we have to look out for. So I'm going to sketch to do the range. So I'm going to plot my vertex, which is 3, 5. So this is 3, 5. Now, I know which way my graph opens. It opens down. So I'm going to sketch that it opens down. So when we're looking at the range, we're looking at the y value of the vertex. So the y value of the vertex is 5. It's right here. So when I look at my range, I'm going to compare my y's to this y right here. Notice all my other y's would be below that because my graph is below this y value of 5. It's below the vertex. So when I say for my range, it's going to be less than or equal to 5. So I just drew this line across to the vertex just to help me identify that's y equals 5. And then I know my graph lies all below that. So I say my range is y is less than or equal to 5. So let's look at another one. So I have 2 times x minus 6 squared minus 8. Start by identifying a, h, and k. So here's a, here's h, and here's k. So I know my a value is 2. So since a is +2, this means my graph is going to open up because a is positive. So it's going to do something like this. The vertex, remember, it's h comma k. H is going to get the opposite sign. So 6 is going to be my h value, and k is going to get the same sign. K is going to get -8. So my vertex is 6, -8. The domain, remember, for quadratics, the domain is always going to be the same because we can put any value we want in for x. It's going to be all real numbers. In other words, there's going to be no restrictions on what we can put in for the x's, but there will be a restriction on the y. So to figure out the y restriction, we're going to graph this. So I'm going to plot the vertex 6, -8. So it'll be about here. And my graph says it opens up based on this right here, based on the A value. So this is what my graph is going to look like. So what I'm going to do is I'm just going to draw a line. Here's my Y value of my vertex. This is Y equals -8 right here. And I'm just going to stretch that across to my graph. The reason why I'm doing that is because I want to just see, does my graph lie above that Y value of my vertex, or does my graph lie below it? So notice my graph is above. So I would say for my range, it's Y is greater than or equal to -8. Because when I stretched this line out, I noticed my graph was all above that line. So my range is Y is greater than or equal to -8. The last one here, similar to what we just did. So I have f of x equals, there's no number out front. We can assume that this is a 1 here. So my A value would be a 1. X minus 1 squared minus 5. So my H would be here and my K would be here. And remember, when we identify our H, we always take the opposite. So for the vertex, it's not going to be -1, it's going to be +1. And my K is going to get the same sign, so it's going to stay -5. Now I'm going to plot this on this grid. So I'm going to plot the order pair 1, -5. That's going to be right here. Now, I know what way the graph opens because I identified A. A is +1, so that means my graph is going to open up like this. So this is what my graph looks like. Now, the last thing we want to do is describe the transformations. So let me zoom out a little bit. So to describe a transformation, so it says translated horizontally. Horizontally means left and right. So horizontally, you're looking for your H value. So my H is 1. So I move my graph 1 unit to the right. So remember, inside that -1, remember inside with the X moves the graph left and right, and it always does opposite. And then vertically means up and down. So you're looking at the K value for that one. So this moves my graph, this -5 moves my graph 5 units down. So this does it for the notes on graphing quadratics day 1.